Hello folks, and welcome to topic 8.1, which is the Pythagorean theorem, which hopefully is reviewed to you. I know a lot of you have seen this before, and its converse, which will, we don't need that, which is basically the flip of the Pythagorean theorem. Your learning objective is, I am learning to use Pythagorean, and let's start abbreviating here, Pythagorean theorem and its converse. And you're going to see that we have actually a key term here for the first time in a while. Your key term is a Pythagorean triple. And all that is, Pythagorean theorem is a squared plus b squared equals c squared. And this is only for right triangles, where c is the hypotenuse, or the longest side. And the way that you know which side the hypotenuse is the right angle is an arrow pointing toward the hypotenuse. You always want that longest side to be C. Your Pythagorean triple are just A, B, and C that satisfy the Pythagorean theorem. Now, example 1 says, find the length of the hypotenuse, which has to be C, and do the lengths of the sides form a Pythagorean triple. Well, if we can find C and plug it into A, B, and C here for the Pythagorean theorem, that means it is a Pythagorean triple. So let's give it a go. A and B are interchangeable. C is the most important side. It has to be in the right location. So C has to be the side that this arrow is pointing at. And then A and B, you could flip-flop, it doesn't matter. Now, whenever you substitute these into the Pythagorean theorem, which is a squared plus b squared equals c squared, this is what you're going to get. Don't forget to square. Some people forget that, raised to the second power. Then you want to simplify. So 21 squared is 441, and 20 squared is 400 equals c squared. Then once you start reducing, you'll get 841 is equal to c squared. And to get rid of the squared, we want to take the square root. And we'll get the square root of 841 is equal to c. Now, this is a perfect square, so if you stick it in the calculator, you get a decimal, you'd have to do either Homey method, or you would have to do a perfect and a non-perfect square. But if you stick this in your calculator, since you don't get a decimal, we can leave it as 29. The second part of the question says, are these sides a Pythagorean triple? Which means if we were to substitute them into the Pythagorean theorem, do you get the same amount on both sides? And here we of course got 841. Here we get 841 a second time, so yes. Example number 2. And again, if y'all have any questions, like I said in the last video, just comment them below, or you can shoot me a remind text or an email and I'll get back to you. Find the value of C, do the side lengths form a Pythagorean triple. So we're going to repeat that process. C is your longest side, and then A and B are kind of interchangeable. So we'll get 65 squared plus 72 squared is equal to C squared. And whenever you start to simplify, 65 squared, big number here, 4225. 72 squared, another big number, 5184. And you want to combine those two to get 9,409. Now when you put this in your calculator, taking the square root on both sides, hopefully you will not get a decimal. And we don't. We get 97. So that is good news for us. We don't have to do Homey method or a perfect and a non-perfect square. To plug those in, it would be 65 squared plus 72 squared equals 97 squared. And if you get the same value on both sides of the equal sign, that means, of course, both sides are equal, meaning these are a Pythagorean triple. So I guess on example 1, we should say yes, Pythagorean triple. And again down here, yes, Pythagorean triple. Example number 3 says find the value of x, leave your answers in simplest radical form. That means no decimals are allowed on this. This is a different type of problem because your A and B value aren't both given this time. Now C is, remember C comes from the arrow. It's the longest side, so it's 20. A and B are interchangeable. So 8 squared plus x squared is equal to 20 squared. And then you want to simplify this. You get 64 plus x squared equals 400. And then minus 64 on both sides. And if we get a decimal here, that is not allowed. So square root of 336 is a decimal. So we want to find either the largest perfect square that goes evenly into 336, or we want to do the homie method. I'm going to do the homie method on this one. What that means is you make a factor tree and you break it down. So I know 3 goes evenly into this because 3 divides into 3 once, 3 divides into 3 once, 3 divides into 6 twice. 112 is an even number, so I'm going to break it down as 2, and I believe that's 66. Nope, 56. I was wrong. And then we can break 56 down as 2, and I believe 28. Yes. And 28 is 2 and 14, and 2 and 7. And then I like to bring all these down to the same location so I don't forget any. And then you can pull out pairs of numbers that are exactly the same. So for instance, there's a pair of 2's here, so we can bring that outside. A pair of 2's here, we can bring that outside. And then we leave the 3 and 7 still inside. And then you simplify by combining the 2 and 2, which are multiplying, and the 3 and 7, which are multiplying. This would be our final answer, 4 square root 21, which I know is weird, but that's okay. I don't know why I wrote 31. It's supposed to be 21. Example number 4 says find the value of x. Leave your answers in simplest radical form. So we're just going to repeat the process that we were just doing. A and B are interchangeable, but C has to be 15. So we're going to do 7 squared plus x squared equals 15 squared. Again, simplest radical form, so no decimals here. And we're going to simplify. Subtract by 49 on both sides. Oh, forgot my squared. Take the square root, and if you get a decimal, that is not allowed. And I got 13.2, so we're going to have to break this 176 down as a perfect and a non-perfect square, or do the homie method. Now I'm going to try the perfect and non-perfect square on this one, but it may take me a little bit longer. So 176, I'm dividing it by perfect squares, which are like 1, 4, 9, 16, 25, 36, and so on. I want the largest perfect square that goes evenly into it. So I'm going to start with maybe 81, which is 9 times 9. That doesn't work, so I'm going to do 8 times 8, which is 64. Got a decimal, so that's no good. 7 times 7, which is 49. That's no good. 6 times 6, which is 36. 5 times 5. 4 times 4. Oh, I got one. 16 and 11. I don't know if you can see that, but this could break down as the square root of 16 times the square root of 11. And the square root of 16 is 4 root 11. And if it said decimals, you could just use that decimal. Example 5 says, is this a right triangle? And example 6 says, classified as acute, obtuse, or right. Now the test to see is it a right triangle, an acute triangle, or an obtuse triangle is theorems 8.3, 8.4, and 8.2 is just for right triangles. Basically what it says is if you were to do Pythagorean theorem for your sides A, B, and C, if they come out to be equal on both sides, in other words, if 84 squared plus 13 squared is the same value as 85 squared, yes, this is a right triangle. If this number's bigger, it's obtuse. If this number c squared is smaller, it's acute. And that's what it says here. If c squared is bigger, it's obtuse. If c squared is smaller or less than the sum of a squared plus b squared, it's acute. So you want to put c squared. I normally put it on the left, which is what I'm going to do here on example 6, but let's see if these are the same value. So 84 squared plus 13 squared gives me 7,225. 85 squared gives me 7,225. So yes, this is a right triangle. If c squared had to come out bigger, it would have been obtuse. If it had come out smaller, it would have been acute. So we're going to say yes, right triangle. Remember, C has to be the largest side. So here the largest side is 14, and then A and B are interchangeable. So if we substitute them into the Pythagorean theorem, I'm actually going to put 14 squared over here to see, is it bigger, smaller, or equal to 6 squared plus 11 squared? 14 squared is 196. 6 squared and 11 squared, when I add them, gives me 157. Now, since c squared is greater than, this will make it obtuse. If you got questions, let me know in the comments or shoot me a text or an email.